Hey there, CJ Math students, and welcome to Note 6.2. So today we're still on one-step inequalities, but today we're going to work with multiplication and division because there are some interesting implications when what happens to the inequality sign when we divide or multiply by a negative. So just as a review, when I'm talking open circle or closed circle, that's a greater than or less than sign. Those have open circles, less than pointing to the left, greater than pointing to the right. Closed circles are these less than or equal to. So less than close to the left, greater than or equal to close to the right, because these guys include the solution, right? So for instance, like if I had x is greater than or equal to 5, like 5, I have a closed circle at 5 because 5 is less than or equal to 5, right? Here, if I have x is greater than 5, I don't include 5 because 5 is not, I put a slash to that, greater than 5, right? 5.00001 would be the first number that would be greater than 5, right? So that's why we have an open circle at that number, all right? So for question 1, right, to solve this, we just divide both sides by 2, right? 2 times some number equals 2. Your answer is 1. So just a closed circle at 1. Remember, an equation just has one solution, right? 1 is the answer there. An inequality, though, says, okay, 2 times some number will give me greater than 2. Well, think about that. I could do 2 times 1, but that's equal to 2. So it's going to be any number greater than 1 would be a solution to this. So you would have an open circle at 1, and then you would drag this all the way through the end here, all the way through, all right? And so that makes sense because 2 times 2 is 4, which is greater than 2. 3 times 2 is 6, which is greater than 2. And we could go on to infinity, right? All right. To solve an inequality, you solve it like an equation and use the inequality sign. That is a true statement, all right? Practicing on these, here we just divide by 6, divide by 6. This is x is greater than or equal to 3. And this, if I were to graph it, here's 0, here's 3. This would be a closed circle because it's the greater than or equal to sign pointed to the right. So 4, 5, 6, 7, all the way to infinity. Those are solutions, right? 6 times 3 is 18, which is greater than or equal to 18. 6 times 4 is 24, which is greater than or equal to 18. It's greater than, right? And then 5, right? But perhaps, like if I made a mistake and drew it to the left, like 2, if I plugged in 2, 6 times 2 is 12. That is not greater than 18, so I know I've drawn it the wrong way. You can always check to see if you've drawn it the right way. On B, obviously, all we do is just times 6, right? And so x is greater than or equal to 18. So again, if I were to draw this, you always just put a 0 and then like mark out where 18 you think would be. And again, it's a closed circle, and think about it. I want any number I plug in here to be greater than or equal to 18. So equal to 18 and greater. So 19, 20, so pointed to the right, right? Great. Second question. Graph the solution. Again, all we're going to do is divide by 6, divide by 6. So x is greater than or equal to 5. So what is this? It's a closed circle and pointed to the right because we're looking for all numbers bigger than 5. So closed circle at 5 and then everything pointed to the right. Right? Here, times 8 times 8. Cancel it out. X is greater than or equal to 48. So again, closed circle at 48 because it includes 48 and everything bigger, everything to the right. All right, so which values make the inequality true? If I divide by 3, I get x is greater than 2. So I want every number that's bigger than 2. Bigger than 2, right? It can't be equal to 2 because 2 is not bigger than 2. Like 2.1 is bigger than 2. Oops, sorry, bigger than 2. All right, so everything that works is 16, 13, 9, 0 doesn't work. 6 definitely works, all right? Great. Here, finding the solution again, divide by 6, divide by 6. I get x is greater than or equal to 3. Oh, I think I just repeated that. Yeah, I did. Sorry, we can cross that off. My fault. Here, same solution. Divide by 4, divide by 4. X is greater than or equal to 3. So closed circle at 3, and then everything bigger than 3 pointed to the right. Here, times 9 times 9. Some of you want to say times 7. Remember, you want to work with the number on the side with the variable. So that's why I do times 9. So x is greater than or equal to 63. Again, closed circle because it includes 63, and then everything bigger, or everything to the right of 63. All right, lastly here, times 10, not times 5, because again, 10 is on the side with the variable. So those cancel out, and x is less than 50, right? Chloe wants to spend at most $176 on video games. So she doesn't want to go bigger than 176. So 176 will always be greater than or equal to whatever Chloe wants to spend, right? She doesn't want to spend 177, right? If each video game costs 39, so 39, what is the maximum number she can buy? So 39 times X is less than or equal to 176. So now we just have a one-step equation where we do 176 divided by 39. And when I do that, I get this crazy decimal, and you guys might want to freak out. You're like, I don't know what to do, crazy decimal, like 4.5128, whatever. So think about it. She could buy 4 games because at $39 each, 39 times 4 means that she'll be able to spend $156, which is less than or equal to 176, right? She can't buy 5 because if she bought 5 games, 39 times 5 is 195, and so 195 is not less than or equal to 176. So in this case, she can buy 4 video games. That's the end of part 1.